Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0983 indicates an issue with the Shift Solenoid Valve D in your 2011 to 2015 Honda Civic. This code points to an open circuit problem within the electrical system, meaning there is a disruption in the wiring or connection that controls this component. Understanding this code is essential for effective troubleshooting as it directly affects the transmission's operation. As part of the diagnostic process, both freeze data and onboard snapshots should be recorded using the Honda Diagnostic System HDS to collect necessary data before proceeding. The shift solenoid plays a vital role in managing gear shifts. If malfunctioning, it can lead to shifting issues in your vehicle. It is important to note that this DTC cannot be attributed to mechanical issues within the transmission itself, which simplifies the troubleshooting checklist. The Shift Solenoid Valve D is an important component of the transmission system in your Honda Civic, primarily responsible for controlling the movement of hydraulic fluid to engage or disengage gears. This valve is located within the transmission assembly and is connected directly to the powertrain control module, or PCM. The PCM is a crucial device that governs various engine and transmission functions, enhancing performance and efficiency. The role of the solenoid is to respond to electrical signals from the PCM, activating the necessary shifts in the transmission. If there's an open circuit detected, as indicated by DTC P0983, this means that the electrical signal is not reaching the solenoid valve, which could hinder the vehicle's shifting capabilities. Understanding this relationship between the shift solenoid and PCM helps in diagnosing the root cause of the issue more effectively. The DTC P0983 is primarily caused by problems within the electrical circuit associated with the shift solenoid valve D. Common issues include frayed or damaged wiring that could disrupt the flow of electrical signals necessary for the solenoid's operation. This may also entail poor connections or loose terminals at various points, including connectors between the shift solenoid and the PCM. It's crucial to proceed systematically in identifying these problems, as they are not related to mechanical malfunctions in the transmission itself. Ensuring proper diagnosis will often prevent unnecessary replacements of components that may still be functioning. Rather, it's the supporting wiring or connections that may be at fault. When the P0983 code is triggered, several symptoms may manifest, primarily related to the vehicle's transmission behavior. One of the most common symptoms is an inability to shift gears smoothly, which may result in hard shifts or even the transmission failing to engage in certain gears. Drivers may also notice a persistent check engine light on the dashboard, indicating that the vehicle's onboard diagnostics have detected an anomaly. Additionally, the vehicle may enter a failsafe or limp mode, which limits performance to prevent further damage until the issue is resolved. Recognizing these symptoms quickly can prevent larger transmission issues down the line and improve overall vehicle safety. The first step in troubleshooting DTC P0983 involves verifying the problem. Start by turning the ignition switch to the on position without starting the engine. This activates the vehicle's electronic systems. Next, utilize the Honda Diagnostic System HDS to clear any existing DTCs. This step resets the diagnostic system and allows you to capture current data accurately. After clearing, start the engine and shift into neutral while pressing the brake pedal, maintaining this position for at least 1 second. Finally, check for any pending or confirmed DTCs with the HDS. If DTC P0983 is indicated upon this check, the failure is replicated, which serves as a confirmation to continue to the next troubleshooting step. In this second troubleshooting step, The operation of Shift Solenoid Valve D needs to be assessed using the HDS. Access the miscellaneous test menu on the diagnostic tool and select Shift Solenoid Valve D for testing. Listen carefully for a clicking sound during the test. This audible feedback indicates that the solenoid is functioning as expected and receiving electrical signals. If a clicking sound is present, it confirms that Shift Solenoid Valve D is operational and allows you to advance to the next step in diagnosis. However, if no clicking sound is heard, this suggests that further electrical issues may be at play, necessitating a comprehensive inspection of wiring and connections. The third troubleshooting step focuses on checking the onboard diagnostics OBD status following a test drive. To perform this, drive the vehicle in third gear with the shift letter positioned in drive D for a minimum of 1 full second. This test simulates normal driving conditions, allowing the vehicle's systems to update any status changes. After completing the drive, monitor the OBD status in the DTCs menu on the HDS. If the HDS indicates that the status is failed, this confirms that the fault still exists, allowing you to proceed further in the troubleshooting process. On the other hand, if the HDS shows past or intermittent failure, it signifies that the system appears normal at this moment, though it's prudent to check for any poor connections or loose terminals in the next steps. In this critical fourth step, the internal resistance of Shift Solenoid Valve D needs to be evaluated. To begin, turn off the ignition switch to the lock position. Subsequently, jump the SCS line with the HDS, a necessary step to bypass certain circuit checks during testing. Disconnect the PCM connector B, specifically the 49P connector. You will then measure the resistance between the designated test points, PCM connector B, number 32, green-red, and body ground. For a properly functioning Shift Solenoid Valve D, the resistance should read between 13.8 to 17.1 ohms. If the reading falls within this range, the solenoid is functioning correctly, and you would proceed to check if the PCM requires a software update. However, if it fails this check, move on to the next troubleshooting step. The fifth step entails conducting an open wire check on the SHD line, focusing on the integrity of the wiring harness. Begin by disconnecting the Shift Solenoid wire harness 8P connector to isolate the electrical circuit for inspection. With both the wire harness and PCM connector B disconnected, check for continuity between test points on the SHD circuit. These points are identified as Shift Solenoid wire harness 8P connector number 5, GRN red, and PCM connector B, number 32, GRN red. If there is continuity, it indicates that the SHD wire is intact, allowing you to move on to the next step. If continuity is not detected, this suggests an open circuit, indicating that repairs must be made along the SHD wire to restore proper electrical connection. In this sixth step of troubleshooting, you'll examine the condition of the Shift Solenoid wire harness directly. To start, disconnect the Shift Solenoid wire harness from the vehicle. Following this, check for continuity between the designated test points. Shift Solenoid wire harness 7P connector number 4, yellow, and Shift Solenoid Valve D 1P connector number 1, yellow. Both connectors should be removed to ensure accurate measurements. If continuity is detected, this confirms that the wire harness is functioning properly, and the next step would involve replacing the Shift Solenoid Valve D if applicable. Conversely, should continuity not be found, this indicates a problem within the wire harness itself, necessitating its replacement to restore proper function in the solenoid and overall transmission operation. The final repair verification step is essential to ensure that all issues are fully resolved. Begin this process by reconnecting all previously disconnected connectors, making certain they are secured properly to avoid any potential loose connections. After everything is back in place, turn the ignition switch to the on position again. Use the HDS to clear any diagnostic trouble codes that may exist. It's important to start the engine with the shift lever in park, P, for at least 1 second before shifting to neutral, N, while still pressing the brake pedal. This step allows for recalibration of any systems affected. Once you've completed these actions, monitor the OBD status in the DTCs menu to check if it indicates passed, which confirms that troubleshooting is complete. Should other codes appear, further investigation will be necessary. To avoid encountering DTC P0983 or similar issues in the future, it's crucial to establish a routine preventive maintenance schedule. Regularly inspect the wiring that connects to the shift solenoid valve and the PCM for any signs of wear, fraying, or damage. Ensuring that connectors are tight and free from corrosion will help secure reliable electrical connections necessary for the solenoid's operation. Furthermore, periodically check if the PCM software is up to date, since manufacturers often release updates that can refine performance and resolve existing issues. Taking these proactive measures can significantly enhance your vehicle's reliability and prevent unexpected transmission problems, resulting in a smoother driving experience. In conclusion, addressing DTC P0983 requires a clear understanding of the potential causes, symptoms, and effective troubleshooting steps. Recognizing that this error is linked to the electrical circuit of Shift Solenoid Valve D, rather than mechanical issues, simplifies the diagnosis process. Each troubleshooting step, from verifying the problem to examining resistance and wire harness checks, plays a critical role in isolating the exact fault. Implementing thorough testing with the Honda Diagnostics System, HDS, ensures accurate identification of issues, resulting in better repair outcomes. Finally, establishing preventive maintenance routines helps in warding off similar problems in the future, thereby maintaining optimal performance and safety of the vehicle. By adhering to these guidelines, you can keep your Honda Civic running smoothly for years to come. Please like and subscribe to the channel. See you next time.